Welcome, everybody. This is section 7.1, confidence intervals, and it's a quick introduction to confidence intervals. The actual work starts in 7.2, so there's not a lot of work to do in this section. There's some definitions and stuff, but basically a confidence interval is what we're doing set in chapter 7. Confidence interval asks us, how sure are we that the data is going to fall in a certain range? You know, what percent sure? Like, I'm 90% sure everybody's going to score between a 60 and a 90 on the test. So how confident are you that the data will fall within a certain range? That's what a confidence interval is. Trying to get data to fit in a certain range. And so once again, inferential statistics is an estimation. It's your best guess. And a lot of times it's a guess. Let's just read this example. For each dollar you pay in county property tax, 22 cents goes to incarcerating prisoners. Goes to your county jail. That's not a fact. It's a guess. It's about, it could be 22.1 cents. It could be 18.9 cents. But they're saying 22 cents covers the cost of incarcerating prisoners for each dollar you pay in taxes. So that's called inferential statistics. The amount of money you spend compared to the amount of money you had, and then if you look at the taxes, okay, about 22 cents. It'd be really hard to predict that exactly. So it's your best guess. It's an estimation. That's inferential statistics, your best guess. Let's see what else. The rest of this, not too worried about. Once again, a confidence interval. That's what we're doing. It's an estimate of a parameter. You're guessing that your data is going to fall, the low end. The low is always going to be on the left side, and the high is always going to be on the right side. So if I said if I did a confidence interval for your grades on the next test, like I said, I'm 80% confident most of the grades are going to fall between 60 and 80. I'm 80% confidence. Now, that means I'm 20% confident that they won't. Some of them won't. But I'm predicting about 80% will fall into that range. That's a confidence interval. You want to try to fit data within a certain range. And you can be 75% confident, you can be 90% confident, you can be 99% confident, and so on and so on. So you can be confident a lot of different percentages, and we're going to deal with that. I still can't get these ads off of my computer. So let's take a look. I'm still going to go. There's really not a lot here. Let's take a look at a degree of confidence must be assigned before the interval estimate is made. Do you see you could be 95% confident, you could be 99% confident, and basically, if we look at grades on a test from 0 to 100, if we look grades on a test, if I say I'm 80% confident, that means I could probably get, 80%. I can probably fall within this range. I don't know what that range is, but it's that range. If I say I want to be more confident, I can say I'm 90% confident for the blue because I've widened it out. And then if I want to widen it out some more, I could say from here to here, I'm 99% confident your grade will fall into one of these categories. The more narrow you have, the less confident in reality you are, right? Because if I say I'm 80% confident your grades will fall in this range, well, if you score really low or you score really high, you're not within that range. So what this says is to increase confidence, the interval must be made wider. Do you see? This is 80%. This is 90. If I really widen it, I can do 99%. So the higher percentage confident you are, it's the wider you're laying your minimum and maximum, your guidelines there. Once again, this is just a really quick intro. There's not a lot of math in this first 7.1 section. Okay, so this is a formula we need to write down. This is the confidence interval formula, and we write confidence interval oftentimes with a CI, confidence interval. This is the formula. Remember, this is the mean. That's the sample mean, or you just call it a mean. We can call this is the population mean. I'm sorry, this is the sample mean. This is the sample mean. This is the population mean. There's a standard deviation, and N is the number of samples, right? The number of samples. So our formula is the mean plus or minus. Now this, you got to be careful. It says 1.96, so that's not necessarily the formula. The formula looks like this, the Z alpha over 2. This is how confident you are, the confidence interval, the actual confidence interval. And it shows you that if you use 95%, then you have to change 95% to plus or minus 1.96. So this 1.96 is 95% confident. And I'm going to look at that and show you which numbers to use in a little bit. So times your standard deviation divided by the square root of the number of items that we're talking about. That's the standard deviation. This is the number of data points. Okay, so this is the confidence interval formula. The mean plus or minus the confidence interval percentage times standard deviation divided by the square root of the number of data points. It says there's a table E that shows you this right here. See, this is that Z alpha over 2 I was talking about. That's your confidence interval percentage. And there's a table that talks about that. So let's look at the table as we scroll down. Here it is. If you looked and we said 95%, we change that to 1.96. Do you see? If we say it's 95% confident, we put 1.96 in here. If we say we're 99% confident, if we say we're 99% confident, then we put 2.58 in here. So it tells us the Z-score for certain confidence that we put in here. All right. Also, if you look at this, it's the mean is in the middle, and you add the confidence interval part to the mean to get the high side, and you subtract it from the mean here. Do you see we're subtracting it from the mean to get the low side? Low. There's always going to be a low side on the left and a high side on the right. This is a confidence interval. We're going to talk about the low number and the high number and how confident we are of getting data within that boundary. This right here, we often refer to it as the margin of error. This plus or minus, this is the margin of error. So do you see all of this part right here? So this is the mean. Do you see? Here's the formula again. Let me write it over here. You can do the mean, and on the right side, you do plus the margin of error. Do you see? This is the margin of error. And then we have the mean here, and then you do the mean minus the margin of error. This is the margin of error. Here's the mean minus the margin of error. Here's the mean plus the margin of error. So big E is the margin of error, so you need to have this formula written down also. Our confidence interval formula, this thing, and the margin of error. This part here is called the margin of error. Okay. So, we only have a couple of questions and then we're done. So let's take a look at these questions. It says determine the margin of error. Remember the formula was there's a mean, here's the formula, there's an average in the middle, and we take the average and we add the margin of error. We take the average and we subtract the margin of error. So the mean, this is the mean in the middle. This is the mean in the middle right there. So this is where I added a number to the mean. This is where I subtracted a number to the mean. The first thing we need to do is find the mean, even though we want to find E. Margin of error is E. We need to find this E. But in order to find E, the first thing we need to do is find U, the average. And the average equals the high plus the low divided by 2. So let's do that. 90 plus 63 divided by 2 on my calculator. 90 plus 63, enter, 153, divided by 2. So the mean for this problem is 76.5. In other words, this middle number is 76.5. Can somebody tell me what the margin of error is now? What does E equal? Can somebody tell me? We know this is 76.5. We know this is 76.5. Can somebody tell me what E equals now, the margin of error? Just checking to see if anybody can look at this and tell me the answer. Just checking. Is this microphone on? Anybody there?
Yes. I just don't know the answer.
Okay, so the margin, look, the margin of error is the average plus the error. The error, margin of error is the average plus the, if we know the average is 76 plus the error, and then it's going to equal 90, or 76.5, sorry. So we just subtract 76.5 from 90. 90 minus 76.5. 90 minus 76.5. And I get 13.5. That's my margin of error. Do you see, if I take the on this side, if I take the average plus 13.5, I get 90, like I said here. If I take the average on this side, 76.5 minus the error, 76.5 minus 13.5 is 63. Do you see? So the margin of error, the plus or minus, is 13.5. So you find the average between these and then find out how far apart they are. They're going to be the same on both sides. And they are 13.5 away. Do you see? If I add 13.5, I get 76.5. If I subtract 13.5, I get 90. So, or 76.5 plus 13.5 to 90, 76.5 minus 13.5, and I get 63. All right, let's try another one or something similar. Actually, I'm going to do another one of these before, because I only have one more question, I think, and then we're done for the day, which is crazy. Yes. So I want to do another one. So I'm just going to, before I look at this, I want to do another one for us. Let's say we have the mean of So I have this. I need to find the mean and I need to find the margin of error. So the mean is you add those two up together, 84 plus the average of those two numbers.
81.
Wait, by the way, I have it. What's wrong with this? Thank you. I have this in the wrong spot. The low number is supposed to be on the left. What was it? 78 and 84. The low number has to be on the left side. So when you add those two up and divide by 2, somebody already said the answer was 81. So that's the mean. So what's the margin of error then?
3.
Yeah, it's 3. Do you see? If this is 81, if I add 3, I get 84. If I subtract 3, I get 78. The margin of error is 3. So first you find the mean, the average between the two, and then going to the right, you have to add it to how many do you add, and going to the left, you subtract. You should be getting the same number on both sides. Both sides won't be different. They'll be the same number on both sides. That's it. That's pretty much 7.1. Now, another way of writing this, let me show you another way of writing this. Another way of writing this is the mean plus or minus the margin of error. We could write this, the mean was 81, plus or minus the margin of error was 3. You see, you could write it like this. 81 plus 3 is 84. 81 minus 3 is 78. Once again, this is the confidence interval. 78 is the low, 84 is the high. But this is another way of writing it. This is the mean, and this is the margin of error. All right. So now we'll be able to do the last one. Determine the margin of error. Well, remember the formula I just wrote down. Plus or minus, here's the mean, and this is the margin of error. So can somebody tell me the margin of error? It's right there. It's all laid out for us already. Do you see? This is the mean plus or minus the margin of error. So that's the answer. They just wanted to verify that you understand. Now, if let's also write the confidence interval. It's 0.12 plus 0.001, which I get 0.121 then. And if I do 0.12 minus 0.001, I get 0.119. So this is the confidence interval. 12, you subtract the, this was really So 120, you subtract 1, you get 119. 120, you add 1, you get 121. So this is the confidence interval. But they just said, what is the margin of error? The margin of error is whatever you're plus or minusing. You add it to the right side to get the high side, and you subtract it to the left side to get the low side. And now you're done with 7.1. That's it.